If you're like me, who's been working more and more with larger code bases using Cursor, I'm sure you felt the pain of getting AI to implement a new feature and only realizing that it's broken something a few commits down the line, and then you went into a horrible debugging session taking you absolute ages before you figure out the problem. That's one of the happy problems that we currently have with all of the AI toolings out there. It's allowed us to ship so much faster than ever before. Testing has now become even more important than ever before to ensure that at the pace that we are shipping, we are making sure that everything still works as we move rapidly forward. In this video, I'm going to talk about how you can leverage test to ensure you write more robust code together with AI and use AI to generate all of those tests for you so that you can enjoy the efficiency that AI brings you, as well as the robustness testing also brings you in the long term. Want to learn how? Let's dive in. Today's video is a bit longer than usual to include all of the useful context. I've included timecodes in the description below, so you can feel free to skip around. There are three main types of testing. There's unit test, integration test, and end-to-end test. We won't get into the debate about which type of test is the best or how you should balance between them. I'm going to say that if you're going to pick one, pick end-to-end test, especially for the early stages of your project, and especially if you're working with a smaller team, because it forces you to test things based on the end user's perspective. It makes sure that you think about test as if you were going on a user journey. The simpler you can write a test, the simpler the user journey. And if you find it difficult to write good tests, it probably also means that the user journey is too complex. So it's a great way to force you to think about the UX of your application while you're writing tests, while making your application robust at the same time. It's a win-win, right? The test framework that we're going to be using today is Playwright, created by Microsoft. It works on all OSs, works across all major languages, that allows you to write simple and easy to maintain end-to-end tests for your web application. We're just going to dive straight into the code examples. We'll continue working on that podcast transcript editing tool that I've been working on for the past few weekends. If you're already familiar with JavaScript test setups, this Playwright test structure should be of no surprise. It uses the exact same layout. Overall, all Playwright tests are just separate into three parts: navigate, take action, check the results of the action. In this case, we're checking that the transcript listing page shows up all of the podcast transcripts correctly. If we just take a look at the current page, you can see we've got two podcast episodes, one where we are the owner of, and the other one was shared by me, and with the title EP1 and EP2. And so in our test, you can see that we get the link to check for the EP1, making sure it's visible, find its parent, and then check that it's correctly showing shared with you. And then you do the same thing for the episode 2. Pretty straightforward, right? And running the test is also as straightforward as writing it. In the command line, all you need to write is npx playwright test --UI, and then it will bring up this lovely UI, which it will show you all of the test suites that you currently have defined inside your entire code base, allow you to run each one of them individually. Let's say we want to choose the transcript list one, we run it. You can actually see all of the actions that it takes, plus all of the validation it does. It also comes with all of the screenshots for the actions you've taken, plus highlighted with a locator, making it super easy to debug what's going on with your application. And we can see that everything is showing up correctly and is finding each one of the elements, checking that they exist. In this test, you don't even need to start up the browser yourself. It does all of that directly for you. Just to test that the test is actually functioning, let's go and break the code and see the test fail. We go into the transcript list, and let's say instead of the created at, we just return a undefined. Edited. We go back, run the test again. The test has failed. When it's looking for the test that shows the date and time of edit, that is not found after the timeout. Okay, cool. Now we know that our test is actually correctly functioning. This means that as you edit your code, whether you're touching other parts of the code base where this component is relying on, you can always be sure that this thing works by simply running the test. This is incredibly helpful the larger your code base gets. I'd say for most toy project that goes beyond 2 weekends worth of work, it's definitely worth starting writing tests, because the number of features that you're going to be adding, it's easy for small changes in one component to be breaking the functionality of another. And I'm sure most of you don't want to be manually testing every single one of the component, every single one of the feature manually after every commit, right? Let's fix the code, rerun the test to see it pass. All good, super quick. you can see that the correct case actually runs faster than the error case. This is because Playwright adds in the timeout and retries automatically when it tries to locate elements on the page, when it tries to do the verification. It makes sure that it allows time for the UI to update, it allows time for the web page to load to make sure the changes are reflected. You can see in our code, we never have to deal with timeouts explicitly in most cases, but even when you do, it's easy to specify. Say, if you know a page is actually slow to load, oh, look at cursor, already knowing that we want to add a timeout, and you can change that directly based on your needs. After looking at all of this, I'm sure you're thinking, oh, do I have to be writing this manually? It looks like still a lot of work, even though the framework has simplified it quite a lot. We can get AI to do most of the work for us. Here's how. We'll continue using my favorite feature in Cursor, Composer, and more specifically, the Notepad feature inside of Composer. We can bring up the Notepad quite easily by just searching for the name inside the Ctrl+P command for navigation. And here, mine was called Playwright End-to-End Test. This was a set of requirements I initially came up with to help Cursor better write the AI tests for me. And after a few iterations, I quickly realized that it wasn't really following a lot of the best practices that Playwright was setting out. Here, I directly use AI chat to help me improve on this Notepad spec. Inside the prompt, I actually pasted the documentation site for Playwright. And if you haven't used this yet, you can do docs, link the docs entry page directly here. And then I've asked it to use the existing Notepad plus the principles outlined in the docs to improve this work for me. You can see that it pulled in the best practices page correctly from the Playwright documentation site, plus a whole bunch of other documentation pages, and then combined what I've already written inside of the Notepad, and then created this way more comprehensive guidelines for the test implementation. Skipping forward a few steps, this is the final Notepad it actually generated for me. This test structure and organization was based on the work that I'd provided it. We specify things, where the tests are located, naming conventions, how you should be grouping the tests, how we should be using the authentication stage, which I'll talk about in a bit, plus all of the best practices is outlined in the docs page. It's even given us a code example at the very bottom. I also spent a bit more time editing this code example to make sure it matches my style. Then it makes it very easy for Cursor to generate new tests based on the existing style that already exists, without you having to mention the context separately in every single one of the chats. It's so much more convenient. Using this new Notepad, I went on to implement the next feature, which was search. I've referenced the end-to-end test, I've referenced the test spec file, plus the implementation components, then just asked it to implement the feature for me for search on the client side. Here you can see that it's implementing the test alongside of the new feature. It's great because you can read the test directly to see how the function is supposed to work. In this case, it checks both items are visible, and then type in EP1 to check that one has been hidden, and then clear the search to check that both still exist, and then type in a name that does not exist at all, and then both should be hidden, and then continue. Inside the component, we can see that it's added a whole bunch of new components, added a new state, plus the input box for searches, and a whole bunch of other things. The only manual work that I had to do here was to add the input box elements through chassis and through npx. After adding the test, again, we can quickly run it through the UI. And then the search functionality here, click on run, the test still passes. You can see it goes to the transcript page, waits for the page to load, checks that both episodes exist, finds the input box by the placeholder, type in the text, and then check that only one exists, clear the thing state resets, type in some other non-existent name, and then it should show no transcripts found. And at the end, resets. How great is that, right? You can see that this feature implementation actually worked on the zero-shot prompt, which I was also quite amazed at because I was expecting some kind of tweaking. After adding that feature, I gained quite a bit of confidence. I decided, okay, I'm going to give it a much larger feature to implement all at once. Obviously, this goes against even the best practice I've suggested in the previous video to break down test. But here, I just want to see how well it does that by creating a decent sized feature together with test all at once. In the next part, I've asked it to add the capability to add a whole feature for uploading the transcript, transcribing, saving, updating the list. So it involves third-party APIs, it involves file handling, it involves front-end changes. So not the simplest thing to implement. I didn't expect it to do it in one shot, but I wanted to see how far it can get. Again, here we specified it must use the notepad. I've asked it to look at the page. For the transcription API, I've used Assembly AI, which is awesome transcription service that works really well compared to all of the other ones I've used. Definitely recommend a try. Here we specify on the homepage, it needs to create a modal and it needs to upload the file, allow us to set the name, use the Assembly AI API to do the transcription, add it to the database, refresh the page, and while it's being edited, it needs to know that it's an asynchronous API and this update needs to happen in the background. Assume the API key already exists. So yeah, not the simpler feature to hit all in one go. Just for safety, I've also included the code-base context just in case it realizes there's other code styles or other libraries it needs to fetch within the code base itself. For this one, I did have to go through quite a few iterations with it. The test wasn't actually the problem. The test almost worked in one go, but it took it a while to figure out how to handle the asynchronous case, how to handle the file upload, and required a few reprompting to get the errors right. But the cool thing is, throughout this entire process, I didn't write a single line of code. I just simply passed on the errors that I saw inside the test back into Cursor Composer to let it debug the problem itself. Overall, it took me about 5 additional prompts to finally get the feature working, just to give you an idea of the size of the change. You can see here, it created a new whole test. The test is actually relatively simple, right? It finds the button for upload new transcript, generates a new transcript name so that our test is isolated, gets a label, fill in the name, attach the file, and then sets the upload, checks for the notification that the upload has completed successfully, reloads the page, and then checks the new transcript is there, right? Because it also needs to handle file uploads, it also created a new API route to handle the file upload case. Here you can see it not only took the upload, but also passes on the data directly to Assembly AI for transcription, and at the end, stores the transcript as the final data. It also created the modal for handling the file input and also the name setting here, as well as dealing with the notification on success and failure. At the end, we also needed to update the transcript list. Overall, not exactly a small change. The only manual work that I had to do there was installing the dependencies for the new UI components it's added, pass around the error messages. There were a few cases where I had to deal with direct debugging to help it move faster, but nothing the AI couldn't have dealt with itself. And now to show you what the test looks like, we go into upload, and you can see also already it loaded the spec directly. We run it. This one is going to take slightly longer time because it will also do the actual transcription on the back end. I generally prefer to use the third API directly during the test because it makes sure that everything is working as if it was being used by an actual user. That gives you the best indication of how well your application is doing at the end. Oh look, everything passed as expected. Going through the test, you can see finds the upload new button, opens the modal, fills in the test name, fills in the transcript name, sets the file, clicks on upload, waits for the success notification, reloads the page. The new transcript that has been uploaded now exists. This is great, right? And even a complex feature like this only took me overall around 30 minutes to implement, and this included doing the test itself. Now I have all of the guarantee that I won't easily break this feature as I modify the other parts of the system. That functionality guarantee is one of my favorite things about doing end-to-end tests, because you know if your end-to-end test pass, then the users must also be having a good time. And of course, after creating the upload feature, I had to immediately create the other counterpart of it, which is deletion, right? Again, given this is a much smaller feature in comparison, I tried this again using a single script. So here, put in the notepad, add in the transcript list, tell it that it needs to be able to delete. For this implementation, it actually made it work in just one go. Well, almost one go, because after the initial implementation, it added everything, all of the functionalities, but forgot to add the test. I had to prompt it again to ask it to add again. The test that was created completely worked after the second go. To give you an idea of the code that was generated, it goes to the transcript page, waits for the page to load, checks the count, finds the first list item, uses the menu to open, clicks on delete, reloads the page, and then checks that the count has gone down by 1, and then the transcript with the original name doesn't exist anymore. It's even added a case where it handles the empty or the having one item left case separately, which is awesome. Inside our data access layer, it's added the additional function for deletion, enforcing the correct user permissions altogether, plus adding the menu again. For this, I also had to manually install the chassis and UI components, but that's a super minor issue. Just for completeness, we're going to run the UI test again. Here, we have the delete. Click on run. It went through just in one go, right? Waits for the page to load, gets a list item, clicks on the menu, clicks on delete. Having every single one of the actions show up and having the screen recorded is absolutely awesome to validate the whole thing works. Reloads the page, the item has gone, and then verify that is the case. That's it. The test has also passed. In just an hour's time, I was able to implement 3 major features while adding tests at the same time. That is crazy efficiency while maintaining the guarantee of code functionality. So you can see when you combine AI and testing at the same time, it makes sure that you can iterate fast while ensuring that nothing breaks, right? It's absolutely awesome. Just to give you an idea of the other tests I also wrote, the moment you have multiple users, you are going to need authentication in your application. So you want to make sure that some pages can only be loaded once the users log in, and some pages are not accessible, and then you redirect users to do the login, and users should only see the files that they really own, right? And then here, I've added a couple of tests to ensure those authentication cases. I've also added a specific test that goes into the details of testing my podcast transcript editing work. So for running all of the tests, you can hit a single button on top. Then Playwright goes into running every single one of the tests as needed, or just wait for all of that to finish. Green ticks all across the board. Awesome, right? So even for the podcast transcript editing one, which is by far the most complex thing I've created, this was also created with the help of AI. You start the edit, you trim the word, you save the trim points, close the session, reloads the page, and checks the trim transcript still stays the same. You can even test for complex user actions like this and always guarantee that things work. For those of you who are also familiar with Playwright, I'm sure you've had the issue of how do you maintain the user accounts for login? How do you test as a logged in user, especially if you're just using third-party OAuth providers? Playwright has also thought about this. You can get through this with a simple and easy command. First of all, you'll want to run Playwright CodeGen, open your website, and then run it with this command line flag with the -- save storage. It saves the storage state, including cookies, plus the local storage context for the browser, into a JSON file that can be loaded in every single one of your tests, which is what you saw inside my test.use storage state in all of my end-to-end tests. If you're interested, comment below and I'll put up a tutorial for anyone who needs it. After all that, I think you'll agree with me that test doesn't seem so bad anymore, right? Especially when AI can write it for us, which is pretty damn awesome. And there's a lot of best practice that has to go in to write these tests well to make it maintainable in the long term. It's one of those things that we can constantly use and update Cursor rules and Notepad feature to ensure we get the most out of Cursor. It's also worth noting that end-to-end test does not replace unit tests or integration tests, especially for mission-critical part of your system that correctness has to be guaranteed. At the end of the day, you always need a combination of unit, integration, and end-to-end test to create robust applications for the long term. If you've enjoyed this deep dive of Cursor's functionality, I'm sure you'll want to check out my other Cursor videos just up there. Until then, Happy shipping, and I'll see you in the next one.